Hello everyone, continuing with the solutions of the problems from exercise 9.1 of class 10th. In this video, we will start the solutions from question number 6 onwards. Question number 6 here is a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walks towards the building. So we have to find out the distance. As we know, in such problems we have to draw the diagram first. And here we are drawing the diagram and describing it. Let AB be the building of height 30 meter. Position of the boy in the beginning is EF and the height of the boy is 1.5 meter. CA is same as EF, so this also will be 1.5. And since AB is 30, AC is 1.5, we can find out the length of BC, and BC here will be 30 minus 1.5, that is 28.5 meter. We have to find out the distance the boy covers from E to D. So we consider this distance as x, let ED be x, and this distance DC be suppose y. Now the angle D is 60 degree and angle E is 30 degree. After drawing the diagram and describing about it, we will start the solution from triangle BDC. So we write in triangle BDC. As we know that the distance BC is given to us, and we have to find out the length y. This is perpendicular, this is base, and we know perpendicular upon base is equal to tan theta. So we will be applying tan theta in this. We write tan theta is equal to, perpendicular means BC, base means DC, theta is 60 degree, so we write tan 60 is equal to BC is 28.5. DC is y, and from the table we know tan 60 is root 3. Root 3 equal to 28.5 upon y. If we transpose y onto this side and root 3 onto this, we will be getting the value of y as 28.5 upon root 3. After finding the value of y, we can go to triangle BEC. So in triangle BCE, or we write ECB, again we use tan theta only. Tan theta is perpendicular means BC, base here is EC. Here we find theta is 30 degree, so we are getting tan 30 degree is equal to BC 28.5 and EC is x plus y. Now we know the value of tan 30 is 1 upon root 3, that is equal to 28.5 upon x plus y in this case. Cross multiplying here, we get x plus y equal to 28.5 root 3. Now we have already found the value of y, and we want to find out the value of x from this. So we will substitute the value of y from this particular equation in this. If we substitute that, we are getting x plus y means 28.5 upon root 3 is equal to 28.5 root 3. Using the transposition, we get here x equal to 28.5 root 3 minus 28.5 upon root 3. We are getting here 28.5 is common. Inside the bracket we will have root 3 minus 1 upon root 3. If we take the LCM, we will be getting the value of x as 28.5 into root 3 as LCM. Root 3 into root 3 will be 3 minus 1. Multiplying this 28.5 with 2 and using the rationalization, we get here 57 into root 3 upon root 3 into root 3. Root 3 into root 3 is 3. So this is 57 root 3 upon 3. 3 cancels this 19 times. So this comes as 19 root 3. So this is the value of x. And that is the only distance the boy has walked towards the building. So therefore the distance walked by the boy is equal to 19 root 3 meter, which is the answer to this particular problem. Dear, this is the solution of question number 6, but by mistake this has been written here question number 5. So make the correction. This is the solution of question number 6. Question number 7 here is, from a point on the ground, the angles of elevation of the bottom and the top of a transmission tower fixed at the top of a 20 meter high building are 45 degree and 60 degree respectively. Find the height of the tower. For the problem, when we draw the diagram, here we consider BC to be the building, A be the point on the ground, and DC is the transmission tower which is on the top of the building. The height of the building is given as 20 meters, so BC is 20 meters. And consider that the height of the transmission tower is h. And suppose this distance AB is x. Then according to problem, angle CAB is 45 degree and angle DAB is equal to 60 degree. We start from triangle ABC. In triangle ABC, we have been given the perpendicular, that is BC, and the base, that is AB, and we know perpendicular upon base is tan theta, so we are applying tan theta in this. Tan theta equal to perpendicular is BC and base is AB. Theta is 45 degree, so we are writing tan 45 degree equal to BC is 20 and AB we have taken as x. We know the value of tan 45 from the table is 1. 1 equal to 20 upon x. Cross multiplying, we get the value of x is equal to 20. Now we use triangle ABD. In triangle ABD, when we apply tan theta, here we find perpendicular is BD and base is AB, and we know theta in this case is 60, so this will be tan 60 degrees equal to BD. BD will be BC plus DC, and that is 20 plus h. AB is x. From the table we know tan 60 is root 3. This is equal to 20 plus h upon x. Cross multiplying, we are getting here x into root 3 equal to 20 plus h. Now if we substitute the value of x from here, that is 20, in this we will be getting 20 into root 3 is equal to 20 plus h. We are to find out h. So we transpose this 20 onto this side and we are getting h is equal to 20 root 3 minus 20. We can get 20 common and this will be root 3 minus 1. So we are getting the height of the transmission tower is 20 into root 3 minus 1 meter. So we can write therefore the height of the transmission tower is equal to 20 into root 3 minus 1 meter, which is the answer to the problem. We proceed to question number 8 now, and that is a statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. When we draw the diagram of it, here we consider AB be the pedestal and BC be the statue of height 1.6 meter. We consider that AB is h, that is the height of the pedestal is h. Point D on the ground is the point from where these angles are 45 degree and 60 degree respectively. Let AD be X. And now we can take in triangle DAB. We find here perpendicular AB and AD is the base. We know that perpendicular upon base is tan theta. So we are applying tan theta in this triangle, and that is tan theta equal to perpendicular means AB. Base means AD. Angle theta here is 45 degree. So this is tan 45 degree. AB is H and AD is X. We know from the table tan 45 is 1. It means 1 is equal to H upon X. When we multiply this here, we are getting X is equal to H. Suppose this is equation number 1. Now we use triangle DAC. In triangle DAC, again tan theta, because perpendicular and base are there, which we have to consider. So here we are taking tan theta equal to perpendicular means AC, base means AD. And theta here is 60 degree. So this is tan 60 is equal to AC. AC is the sum of these two, that will be H plus 1.6 upon AD, that is X. We know the value of tan 60 from the table is root 3. Root 3 is equal to H plus 1.6 upon X. If we cross multiply, we are getting X into root 3 equal to H plus 1.6. From 1, if we apply here, X is H and we have to find the value of X. So X can be replaced by H. We can get here H into root 3 is equal to H plus 1.6. We can write here using 1. And hence we are getting here H root 3 minus H is equal to 1.6 by using transposition. H is common here. So this is H into root 3 minus 1 equal to 1.6. It means we are getting H is equal to 1.6 upon root 3 minus 1. If we use the rationalization, we will be getting here 1.6 into root 3 plus 1 upon root 3 minus 1 into root 3 plus 1. A minus B into A plus B is A square minus B square. So we get here H equal to 1.6 into root 3 plus 1 upon 3 minus 1, which is equal to 1.6 into root 3 plus 1 upon 2. We cancel this by 2. This is 0.8. This is 0.8 into root 3 plus 1 meter, which is the height of the pedestal. And this is the answer to the problem. We can write here the height of the pedestal is 0.8 into root 3 plus 1 meter. Now we proceed to question number 9, which is the angle of elevation of the top of a building from the foot of a tower is 30 degree and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, find the height of the building. According to this problem, we draw the diagram, and in this we have taken AB as the tower, that of 50 meters. CD be the building, and suppose the height of this is H. The angles of elevations are 60 degree and 30 degree respectively. It means angle ACB is 60 degree, angle CAD is 30 degree. And we consider that this distance AC is X. Now we will use the two triangles to find the solution of it. When we go to triangle CAB, in triangle CAB, we are finding AB is the perpendicular, AC is the base, and the trigonometric ratio in perpendicular and base is tan theta. So we will apply here tan theta. We write tan theta equal to perpendicular means AB, base means AC. Theta is 60 degree, so it gives us tan 60 is equal to AB means 50, AC means x. And from the table we know tan 60 is root 3. This is equal to 50 upon x. Using the transposition, we find x equal to 50 upon root 3. This is equation number 1. Now we go to the next triangle, that is CAD or ACD in triangle ACD. Again we have to apply tan theta only, and tan theta here is perpendicular is CD and the base is AC. Theta here is 30 degree, so it is tan 30 is equal to CD. CD is H we have taken, and AC is X. We know the value of tan 30 from the table is 1 upon root 3, that is equal to H upon X. Using the transposition, we find here X equal to root 3 into H. This is equation number 2. We have to find out the value of H, so we will substitute the value of X from equation number 1 in this, and we are getting 50 upon root 3 is the value of X is equal to root 3h, and we can write here using equation number 1. Then we find here h will be equal to 50 upon root 3 into root 3, and we know root 3 into root 3 is 3, so this becomes 50 upon 3. H means the height of building, so we'll write therefore height of the building is equal to 50 upon 3 meter, which is the answer of this particular question. Now we'll proceed to question number 10. Question number 10 is two poles of equal heights are standing opposite to each other on either sides of the road, which is 80 meters wide. From a point on the road between the poles, the angles of elevation of the top of the poles are 60 degree and 30 degree respectively. Find the height of the poles and the distance of the point from the poles. According to the problem, we draw the diagram here. We have taken AB and CD be the poles of equal height, that is suppose H, and P be the point on the road which is of 80 meters width. Let PC be X and AP will be 80 minus X because total is 80 meters. Angles are 60 degree and 30 degree, so we write angle CPD is equal to 60 degree and angle APB is equal to 30 degree. We use the two triangles for the solution. First we take triangle PAB. In triangle PAB, we find that AB is the perpendicular, AP is the base, so we will be using perpendicular upon base as tan theta. And when we get tan theta here, tan theta is perpendicular AB upon base AP. Theta is 30 degree. When we substitute here, we are getting tan 30 equal to AB, that is H. AP is 80 minus X. From the table we know tan 30 is 1 upon root 3, that is equal to H upon 80 minus X. When we cross multiply them, we are getting 80 minus X is equal to root 3 into H. This is equation number 1. Now we go in triangle PCD. In triangle PCD, we have to apply tan theta here also because this is perpendicular and this is base. So we write tan theta is equal to CD, that is perpendicular, CP, that is base. Tan 60 because theta is 60 degree here is equal to CD means H, CP means X. We know the value of tan 60 is root 3. So this is root 3 equal to H upon X. It means we are getting H is equal to root 3 X. This is equation number 2. Now if we substitute the value of h from 2 in 1. We will be getting from 1 80 minus x is equal to root 3 into root 3x. This gives us 80 minus x is equal to root 3 into root 3 is 3x. Transposing this here, we are getting 4x is equal to 80. It means x is equal to 20. If we substitute this value of x in equation number 2, we are getting from 2 h is equal to root 3 into 20. It means 20 root 3. H is the height of each pole. This is the distance 20 meter from one of the pole. Therefore, we can write therefore height of each pole is equal to 20 root 3 meter. And the point is 20 meters from one pole. This is the way we can find the solution of this particular problem. The solutions of the next problems we will discuss in the next video. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.